So in this video, we're going to take a look at 3D coordinates. So we're going from two-dimensional, which you should know, and we're launching a third dimension. So take a look at the diagram in front of you and try to visualize this as three-dimensional rather than two-dimensional. So our original x-axis, look, is the green line I'm just drawing in there, and that original y-axis is there. So far, we would be drawing points on that axis like that. And those are our usual coordinate points. But what if we come off the page? What if we start to think about 3 dimensions? Can we still do the same thing in 3-dimensional space? Well, of course we can. We are going to have coordinate points with 3 numbers in them, right? An X, a Y, and a Z in that particular order. Okay, so let's take a look at a few example questions to help us think about this. Now, often the questions are done on dotted paper to help us understand and think about this, right? But it's exactly the same principle. We have the same situation. Now, I think for all of these questions, right, let's think about our x-axis, look there in red. Our y-axis is going to be in blue. And our z-axis is going to be there in green. Right. So our question in this sense is to write down the coordinates of each vertex of the cuboid, right? And a vertex, of course, means a corner. So let's start here, look, at A. Well, A is at 0, 0, 0, isn't it, right? Okay, we're going to have 0, look, for the x-axis. We're going to have 0 for the y-axis, and we're going to have 0 for the z-axis. Right, what about B? Well, B is over here. Now, easy, you can see straight away we're at 8 on that x-axis. Now, in the y-axis, we haven't moved at all. We're still at 0, and that's the same for the z-axis as well. So that is going to be 8, 0, 0. Okay, moving along then to C. Well, if we think about C, C is going to still be at 8 on that x-axis, but we have moved in the y direction, if you like, the blue direction, I guess. And using those dotted lines, can you see we're meeting up there with the 4? In terms of the z-axis, we haven't come up in any way. We're still flat with the x and y-axis. So we're at 0 in that z direction. Now, on that, we're going to move on to D now. So D is 0 in the x direction because it's on that y-axis. So we have moved 4 places along on that y-axis, but we haven't got any movement up out there, look, on the z-axis. So those lower 4 coordinate points, the base of that cuboid, we've got those answers there. So let's carry on and then go from the top. We'll start now with E. So if we think about E, well, we have a 0 on the x and on the y-axis. It's above the 0, 0, 0 point. That was A. But we do have movement up in that z direction. You can see from the z-axis, it's at 3. If we move around this to F, we are going to have an 8, a 0, and we're still at a height of 3. So the z-axis is going to be 3. Right, moving on. Let's do G. So take a look at G. G has an x coordinate at 8. It has a y coordinate of 4. It has a z coordinate of 3. And finally, let's just finish this off by looking at H. H has an x coordinate of 0. It has a y coordinate of 4. It has a z coordinate of 3. Okay, so those are the coordinate points in 3-dimensional space. Let's move on and see if we can work out one final question. Right, same idea though. Here is a triangular-based pyramid, and it says that D is vertically above A. The base of ABC is a horizontal base, so that means it's flat there against the x and y axis. Write down the coordinates of each of the vertices. Okay, well, let's get started. We'll treat it the same as the previous one. Let's think about our x direction as that being red, our y direction as being blue, and our z direction as being green. Right, so let's start with A. Okay, so A is this point here. Well, I can see that it's 1 across in the x direction, and it's 1 in the y direction. But it is 0 in the x direction. It doesn't have any height. It tells us in the question that we're flat against that x and y axis. Carrying on, let's have a think about the point that's marked as B. Well, we can see that it is at 6 in the x direction. It's at 1 in the y direction. And again, it's flat. It hasn't got any movement up in that z direction. Moving on, let's do C. So C has a x coordinate of 2. Now, this is really hard to see, but we can follow those lines, look, okay, that the dots are on to help us to see that. Okay, and in the same way, we can do the same, look, okay, from that y direction. Can you see that the y coordinate is 6 because we are following the grid lines there, look, okay, that are provided for us. Right, finally, that z direction again, ABC is flat on that x and y axis, so we've got no movement up in that z direction. Okay, now let's finish this off by looking at the point D. So D is directly underneath A, and A had an x coordinate of 1 and a y coordinate of 1, so D is exactly the same. Now, this one does have a height, though, and again, it's really hard to spot, but we can do it because we can follow those dots again. If we matched this up successfully, we can kind of count, look, 1, 2, 3, 4, okay. This is going to have a height of 4, right? There we go. And think of it this way. If we dragged that corner A right over there to that origin point, 0, 0, 0, where would that D line up on that z-axis? It'd be 4 high. So we can count that a height in the same way. Okay, I hope that's helped you to understand how to work with 3-dimensional coordinates. It's hard to visualize in 2-dimensional space, but give it a go and see if you can answer those questions.